Today, we're going deep underground to talk about one of the most incredible machines on the planet, the Tunnel Boring Machine, or TBM. We're going to look at how these absolute giants of engineering went from just being about brute mechanical force to being super smart, data-driven systems that are literally reshaping our world from below. So let's get digging.
I mean, seriously, just think about it for a second. Our biggest cities are packed, they're constantly growing, and they need new arteries. Tunnels for trains, cars, utilities. But how on earth do you build them deep underground without just shutting down the entire city on the surface? The answer is inside one of the most impressive pieces of machinery ever built. And here it is, the Tunnel Boring Machine. Now don't just think of this as a giant drill, that's not even close. This is a subterranean factory on the move. It digs, it removes all the dirt and rock, and it builds the permanent tunnel all in one seamless, continuous motion. It's the whole shebang. To really wrap your head around what these things can do, you first have to appreciate their sheer, unbelievable scale. We are talking about true mechanical behemoths.
Just try to get a picture in your mind of a machine that's longer than a football field, pushing its way through solid rock hundreds of feet right beneath where you might be standing. These things are just massive, unbelievably complex systems, and they're designed for one thing and one thing only: relentless forward progress.
So how does this incredible dance actually work? Well, it's all one perfect continuous cycle. Up front, you've got this massive rotating cutter head that just chews through rock and soil. As it's grinding away, a conveyor system carries all that debris, they call it muck, all the way out of the tunnel. Then, powerful hydraulic jacks shove the entire machine forward, and right behind it, a robotic arm grabs these huge concrete segments and builds the tunnel wall, ring by ring. It's digging and building, all at the exact same time. It's just amazing.
But look, that mind-blowing power is really only half the story. The truly revolutionary thing happening in tunneling today isn't about the steel anymore, it's about the data. This is the big shift from brawn to brains.
You see, for decades, the whole game was just about making TBMs bigger and stronger. Now, the goal is to make them smarter. The next great leap forward isn't going to come from more horsepower, it's going to come from better information.
So this is the new workflow. A modern TBM is covered in thousands of sensors. It's like its nervous system, collecting data every single second on everything. The pressure on the cutter head, the geology it's hitting, how fast it's moving. All that raw data gets cleaned up and fed into machine learning models that can actually start to predict what's going to happen next. And the coolest part? All of this is visualized on something called a digital twin, a perfect virtual replica of the TBM, giving the operators this kind of godlike view of the entire operation from the safety of a control room. So what's the payoff for all this high-tech wizardry? Well, the benefits are huge. You can suddenly predict your progress with incredible accuracy, which means your schedules are actually reliable. You can see when the cutting tools are about to wear out, which saves an insane amount of time and money on replacements. But the big one is that it just lowers the risk of the whole project by letting you solve problems before they even become problems. Now, you might be thinking, okay, these TBMs sound absolutely unstoppable. Why would you ever use anything else? Well, it's not quite that simple, and this brings us to one of the great debates in modern engineering. Is it all about the machine, or is there a better method?
The main alternative is something called the New Austrian Tunneling Method, or NATM. And instead of one giant machine doing everything, NATM is more about using conventional excavators and sprayed concrete to carefully build the tunnel piece by piece. Here's the best way to think about it. A TBM is like a freight train. It is incredibly fast and efficient on a long, straight track. NATM, on the other hand, is like an all-terrain vehicle. It's slower, sure, but it's super flexible and can adapt to anything, changing ground conditions, weirdly shaped tunnels, you name it. It's perfect for things like subway stations.
Which, of course, leads to the big question. If you've got to build a tunnel, which do you choose? Do you go for the high-tech machine or the super flexible method?
And the answer, more and more these days, is you use both. The smartest projects don't pick a side. They use a hybrid approach. They'll use a TBM to blast through the long, straight parts of a subway line at top speed, and then switch over to the more flexible NATM to carefully carve out the massive, complex station caverns. It's all about using the right tool for the right part of the job.
So where does this all lead? When you take this incredible combination of raw mechanical power and team it up with artificial intelligence, what does the future of tunneling look like?
Well, this future is already here. These smart TBMs are out there building modern wonders. They carved out the Gotthard Base Tunnel, the longest railway tunnel in the entire world, straight through the heart of the Swiss Alps.
Over in Istanbul, they dug right under the Bosphorus Strait to connect two continents, Europe and Asia, with the Marmaray rail line.
And then they did it again nearby with the Eurasia Tunnel, using a crazy specialized TBM that could withstand immense pressure to build a double-decker road tunnel deep under the sea. These projects are incredible, but there are still hurdles to clear.
Yeah, it's not all solved yet. There is still some really tough nuts to crack. Predicting exactly when those cutting tools will wear out is still a huge challenge. Managing the stability of the ground right in front of the machine to prevent a collapse, especially when the soil is soft or mixed, that's critical. And of course, the golden rule of AI, your model's only as good as your data. So ensuring that sensor data is clean and reliable is absolutely everything.
So it is absolutely no surprise where all the research and development is focused right now. The lion's share, 40%, is on performance prediction. Basically using AI to get faster and more predictable because in tunneling, time is literally money. Right behind that is making the digital twins and the AI even smarter, and then, of course, tackling the physical problems of cutter wear and building better sensors.
And this really brings us to the core takeaway of this whole thing. It's not just about the machine anymore. The future of building our hidden world lies in this powerful synergy, this fusion of raw mechanical force with the predictive intelligence that data gives us. That combination is the secret sauce that is going to unlock safer, faster, and way more predictable construction for the next generation.
Which kind of leaves us with one final big thought to chew on. We're getting really good at building this entire invisible world beneath our cities and through our mountains. But as our planet gets more and more crowded and the surface gets more congested, what's next? What other incredible, invisible engineering marvels will we need to dream up just to keep our world moving?